As we go into this second chapter on electrochemistry, we're going to be spending a lot of the first half of the chapter talking about how to balance redox equations. You did balance a few redox equations in your first year chemistry course, but what we're going to be doing in this course is going to be quite a bit more in depth and complicated than what we did in your first year course. That wouldn't be too surprising since we're in second year chemistry. I do want to tell you just right at the outset that the method that I use to show you how to balance redox equations is not like either of the methods that he shows you in the book. There's nothing wrong with what he shows you in the book, but I think the method that I show you is going to be much easier to follow, much easier to get the equations balanced without the potential of making mistakes quite as easily. So I'm not even going to have you read most of the first part of the chapter because what I show you isn't in there anyway. When you balance redox equations, it is similar to balancing other equations, but there is an extra twist to it. And that's that you have to make sure that you balance not only atoms, but charge also. If your charge doesn't balance, what that means is that remember that to have a change in charge, you either have to have a change in the number of protons or the number of electrons. Now, because we know that the protons are buried deep within the nucleus of the atom, the change on the atom is caused by a change in the number of electrons. If we suddenly don't have our charges balanced, that means that we've lost electrons or we've gained electrons someplace. And they do have mass, and so if I've gained or lost electrons in an equation, what that means is that I've not obeyed the law of conservation of matter. So therefore, I have to make sure that I balance both charge and number of atoms. Now, you can have a redox equation that doesn't actually change charge from one side of the equation to the other. So if you look at this equation right here, this looks like it should be relatively easy to balance. If I look at oxidation numbers, you'll remember that if I have an element that's by itself, the oxidation number on that is a 0. And so this is going to be the same thing here. The oxidation number here is 0. On when I have antimony chloride, the chlorine is going to be a -1 charge, and the antimony over here is going to be a +3. So you can tell, since the antimony went from a 0 to a +3, that it was oxidized, and the chlorine went from a 0 to a -1, and it was reduced. So this is a redox equation because I have had elements that were both oxidized and reduced. However, and I'm just going to erase these for the moment. The other thing that you can see when you look at this is that there's no overall net charge on either side. So for a redox equation like this, I can just balance this like I always have. I've got 2 chlorines here and 3 here, and the least common multiple of that is 6. So if I put a 2 here and a 3 here, I now have 6 chlorines on each side. And then if I put a 2 in front of the antimony, it's balanced. So that one's not, even though it is a redox equation, it's not difficult to balance simply because the charge is already balanced on each side. So something like that, there's no issue with balancing those. Now, on this side, I have an iron 2 ion plus chlorine yields iron 3 plus and chlorine minus. So you can see the oxidation states written on all of these. The oxidation state, except for this one, it's a 0 because it's just a molecule or an atom by itself. So the iron is going from a +2 to +3, so it's oxidized. The chlorine is going from a 0 to -1, so it's reduced. Now, if you're not careful to balance charge, what you might do is say, well, all I have to do is put a 2 in front of there, and everything's balanced, right? 1 iron on each side, 2 chlorines on each side. Now, I touched on this in the last chapter just a little bit to get you thinking about it, but if I look at the total charge on this side over here, I have a +2. If I look on this side, I have a +3, and I have 2 chlorines at a -1, And so what that gives me is a positive 1 on that side. Well, you can't do that because what that means then is that somewhere I gained an electron. That's not allowed. You can't gain or lose electrons, just like you can't gain or lose, atoms either. So obviously we can't balance the equation just by looking at it like that. So I've got to take into account the amount of electrons that are gained or lost. So this is called the half reaction method. And again, if you notice in your book, he does teach you the half reaction method. And what I'm going to do right now is not that much different from what he shows you, but it's going to change later on. So I just ask you to bear with me for this first section, and then tomorrow it's going to be way different from what he teaches you in the book. So the first thing you want to do when you balance a redox equation, and this is on the balancing half reactions, this is a sheet that I did send to you, so you should have that. So you can see that there. And we're not going to get very far down on that instruction sheet today, but we are just going to start by writing, as in step number 1 shows you, we're going to start by writing the 2 half reactions. We've written half reactions before, so here I'm going to have an Fe2 plus go into an Fe3 plus, and then I'm going to have Cl2 going to Cl minus. So the first thing that I'm going to do is I'm going to balance according to the number of atoms, okay? So I have 1 iron on each side, so this half reaction is already balanced according to the number of atoms. Then, now on the sheet, we're talking about balancing everything except hydrogen and oxygen and adding water molecules and hydrogen ions. We don't need that in the equations that we're going to be balancing today. So I'm going to balance according to the number of atoms. Then I need to balance the charge by adding electrons. Okay, so to get the same charge on both sides of this, with a positive 2 here and a positive 3 here, I need 1 electron on this side, and then now I'll have a positive 2 on each side. Down here, I'm going to balance the atoms first, so I'll have 2 there, so now I have 2 chlorines on each side, but if I look at the charge, I have a 0 here and a negative 2 on this side. So to get this balanced, I'm going to have 2 electrons over here. Now this probably looks similar to what we have already done in the previous chapter, because what we said then was that I can't, in order to have a balanced equation, I can't basically lose an electron here and then gain 2 here. That's not balanced, it just doesn't work. So then I will have to take this entire equation and I'm going to have to multiply it through by 2. Okay, so what I can see now that is going to happen is that I'm going to multiply through the top equation by 2. So I'm going to have 2 Fe2 plus yields 2 Fe3 plus 2 electrons. And then I'm going to have the same equation on the bottom that I already have. Okay. Then I'm going to have to add them together. Now you can see that I've got 2 electrons on this side and 2 electrons on this side, and they're going to cancel out. So that makes my final equation 2 Fe2 plus Cl2 yields 2 Fe3 plus 2 Cl minus. So when you go through and make sure that your equation is balanced, again, make sure that you check both for atoms and for the charge. So for my atoms, I have 2 irons here and 2 irons here. I have 2 chlorines here and 2 chlorines here. So my atoms are balanced. Then I need to check according to charge. I have 2 times a positive 2, which is a positive 4. So positive 4 on this side. I have 2 times a positive 3, which is positive 6, plus a negative 2 from this. And so positive 6 plus negative 2 gives me a positive 4 on this side. So I'm balanced according to charge as well. Okay? So the assignment that I gave you for today isn't going to have anything more complicated than what we just did here. And like I said, it's very similar to what we've already done in Module 9. So I really don't anticipate that you're going to have any difficulty with that.